All right, so we're going to continue finding the derivative using the limit of the difference quotient. And then once we have the derivative, we're going to try to determine any points on the graph where the tangent line would be horizontal, and then find the equation of the tangent line at a given specific point. Okay, so I'm going to do one example with you guys and give you all an opportunity to work on some of the other ones, and you can check your solutions afterwards, either in my School Loop Locker or in Google Classroom. But let's just go ahead and try one, because I think once you get one down, the rest will start to make a little bit more sense, and it just comes to a matter of practicing them. All right, so let's start by finding the derivative, okay? So here's our function, here's a given point, and our first step is just going to be define our derivative. So f prime of x. All right, so we're going to do this again, the same process that we did in the previous lesson, where we're going to find the limit as h approaches 0 of this. So here's the setup. Remember, it's f of x plus h. So we're going to evaluate this function at x plus h. All right, and then we're going to subtract f of x from that. So let me go ahead and subtract all of f of x. Again, be careful with your parentheses here, because that could make or break you in this problem. And then we have all of that over h. So take a moment and clean that all up. So the limit as h approaches 0 of, let's expand all this. Looks like I need a little bit more space. And I think I applied all my signs correctly there. All right, and now that's all over h. Then we're going to find the limit of this as h approaches 0 of h squared plus 2xh minus 6h. All of that's over h. And let me just make sure that I clean that all up correctly. So we had that x squared, negative x squared. We had a negative 6x and a positive 6x. Positive 4, negative 4, and I think I got all of them. All right, cool. So now I see that there's an h in both the numerator and denominator, so I'm going to divide all of those out. And what we're left with is the limit as h approaches 0 of h plus 2x minus 6. So now we're ready to actually find the limit. So what is the limit of this expression as h approaches 0? Well, when h approaches 0, effectively h is 0, we're left with 2x minus 6. So there's our derivative. All right, our derivative, f prime of x, is 2x minus 6. Okay. All right, so now that we have our derivative, let's move on to part B. Part B then is to use the derivative to determine any points on the graph of f of x at which the tangent line is horizontal. And as we saw in the previous problem from the last video, when our tangent line is horizontal, that just means our tangent line slope is equal to 0. So let's write that. The tangent line, and I should move this up here. The tangent line is horizontal when our derivative is equal to 0, right? So our tangent line is horizontal when the slope is 0, which means our derivative is equal to 0. So now that we have our derivative, we're just going to set our derivative equal to 0, 2x minus 6. And so just solving this. So where is our tangent line going to be horizontal? When x is equal to 3. Well, when x is equal to 3, what's our y value? We just want to plug x is equal to 3 back in. But be careful where you plug it in. We're plugging it back into our original function because we're trying to find the y value on our function. So f of 3 of our original function is 3 squared minus 6 times 3 plus 4. So f of 3 is equal to 9 minus 18 plus 4 is negative 5. So make sure you do this, and I'm just going to really just emphasize not f prime of 3. Okay, so make sure that you plug in into the original function. So I can then say the following. I can say the tangent line is horizontal at the point 3, negative 5. Okay, so let's go ahead and box our answers. Ooh, that might be too much to ignore. Okay. Things I do for a clean box. All right. All right, that's pretty good. Okay. Now let's move on to our final part. And our final part was to find the equation of that tangent line at the specific point. The specific point that they're giving us is here, 4, -4. So at 4, -4, let's find the equation of our tangent line. So at 4, -4, okay? So we're gonna need a couple things. First, if it's a tangent line and we're finding its equation, we need its slope. So the derivative evaluated at 4 gives us the slope of our tangent line at that point, 4, -4. So that's 2 times 4 minus 6. So f prime of 4 is equal to 2. Okay? So in other words, we can say our slope at 4, -4 is 2. Okay? All right. Now let's find the equation. Now we're ready for our equation. So for our equation, let's just go ahead and use point slope form. It's probably going to be the easiest one. So we can say y minus y1 is equal to m times x minus x1. Okay. Well, what do we know? We know our slope. So let's go ahead and put that in. And do we know our y1? And the answer is yes, of course we do. We were given the point. There's our x1 and our y1. So for our y1, let's put in -4. And then for our x1, let's put in 4. And just fill in the rest. Okay, so here is the equation of our tangent line. Oops. Doesn't want to listen. There it is. Okay, and there's nothing that says that we have to write this in slope-intercept form. I mean, I guess if I really wanted, I could clean this up and just write y plus 4 is equal to 2 times x minus 4. And let's actually just take this and just move it down there. All right, so there's our tangent line equation in point slope form. And in fact, when you get on to taking calculus at the AP level, you're often encouraged by your teachers not to take the extra steps to convert this into slope-intercept form, because in the process, you may end up making a computational error or some type of error, and what was once a beautiful, perfectly fine point slope form equation is now incorrect. So that's something that we would be discouraged from doing. So just leave it in that form. And so just to finish it off, if I can, let's go ahead and let's start just a new graph, new blank graph. And let's go ahead and let's put in that function that we came up with. So f of x. So where am I? So f of x is equal to x squared minus 6x plus 4. Okay, so there's our function that we had. Let's highlight the point 4, -4. And let's enter in the tangent line equation that we just came up with, just to see if it seems to visually align with what we found algebraically. That's 4. And just making sure everything's correct. And there it is. There's our tangent line.